Hello, my name is John Kelly and this is the Weber Auto YouTube channel. Today we are going to talk about crossover all-wheel drive systems that are found in a lot of vehicles on the road. A lot of technicians and drivers don't even realize there's a difference between an all-wheel drive vehicle that's considered a crossover vehicle and your standard pickup truck or sport utility vehicle in the full size. But this piece that I'm looking at that I'm showing you here is what's called a power transfer unit. And this power transfer unit has some studs right here and some bolt holes, and this entire power transfer unit bolts right up to the side of an automatic transaxle that would be right here. So our engine would be right here in front, the transaxle right here, and this power transfer unit, PTU, as a lot of vehicle manufacturers call it. This particular one is a Toyota one. Toyota just calls all their transfer cases and transfer units, they just call it transfer. But this is a transfer unit that is totally different than a transfer case. And I'm going to show you why, or what's inside of here, what makes it different, and how does a crossover all-wheel drive or four-wheel drive system differ than a standard pickup truck or full-size SUV four-wheel drive system. So one of the first things I want to show you is that I've got an axle shaft here. This axle shaft would come in on my side over here. Let's say that I'm in the area where the right front tire would be. This axle shaft comes all the way through and sticks out right here. So it goes straight through this crossover four-wheel drive, all-wheel drive transfer unit. And it actually engages directly into our differential. So let me slide this off to the side here for a moment. Here's a differential assembly, just a standard open style differential that you would see on any front wheel drive transaxle or any transaxle. And let me bring in a two-wheel drive version. So I've got two different final drive assemblies here. This one is front wheel drive only. This one is all wheel drive, four wheel drive. But what I want to show you is that this axle shaft that goes to the right hand side of the vehicle where we have this is the half shaft. The axle shaft would go out to the tires themselves. These splines that are right here go right into the side gear, and we have our differential gear set in here for differential speeds. When we go around corners, the left front tire turns a different speed than the right front tire when you turn corners, and of course the front tires turn a different speed than the rear tires do. But this also splines right into the same side gears here on the all-wheel drive version. Well, what makes the all-wheel drive version completely different is not necessarily the differential case or of the final drive of the transaxle, but what hooks to it. You'll notice right here we've got a taller area and it has some spline teeth inside of it versus a short area over here. So this is our front wheel drive, two wheel drive version. I'll just get that out of the way for now. And this final drive unit is going to come in and spline directly to the the power transfer unit. So I've got it connected to the transfer unit. The axle shaft then comes all the way through the transfer unit and connects to the side gears, and you can see those side gears right here rotating from the axle shaft. So the power transfer unit has nothing to do with the half shaft and the right hand axle shaft. We still have differential action just like we would on a front-wheel drive only vehicle. But now let's see what's inside of this. What does our final drive differential case actually connect to in here, and where does it go? You'll notice this, if I turn it on its end, this is the output housing right here that would go to the rear of the vehicle. As a matter of fact, I've got a cut off piece of a propeller shaft, drive shaft, that splines right here. This is where the rear propeller shaft would connect on for an all-wheel drive, four-wheel drive system. But let's take a look at these pieces internally. So let me disconnect our final drive. And what I have done is, on another one of these units, I've unbolted this housing right here. So I've got that out of the way. And inside of this housing and this housing, we have a great big pinion gear. Now this pinion gear is rather large diameter for the gear itself, but it still has, just like any other pinion on our front or rear drive axle, it has the pinion bearing. It has a pinion depth shim underneath the pinion bearing. It has a crush sleeve, has a front pinion bearing, and then it has an axle nut that takes a rather large, either 36 or 38 millimeter special socket to remove this, and it is staked in place, so it's a locking nut. But this entire thing is in here, and you have to take off this housing to get to that nut. So once you get the nut off and get this out of the way, then we'll go to the front of the differential housing here and pull off the cover. We'll get that cover out of the way, and inside of that housing, as you can see right here, we have a little tiny ring gear. A little baby ring gear. It's a 6-inch diameter ring gear. It's on its own differential case, except I want you to notice that even though I said differential case, this really has no differential gears. It's not an open differential. It's not a posi. This would be what would be considered a spool, a direct drive. It allows for no slip at all. And notice there's some splines here on this differential case that the ring gear bolts to. And if we bring the differential case in for the final drive, for the transaxle, we've got some splined teeth right here that are going to mesh with these splined teeth. So let me get that lined up. So now we've got the front final drive differential. This particular one, let's see, this was a 2010 Lexus RX 350. So very similar to a Toyota Highlander. The final drive gear ratio of this transaxle. So we've got a idler gear here that drives, that's the equivalent of a pinion gear on a ring and pinion gear set, that's going to drive this ring gear. It has a gear reduction ratio of 4.356 to 1. So that's a pretty low gear ratio. You'll get some good acceleration out of that. And so that means this entire housing here turns one time for every 4.356 turns of the input shaft of the transmission, so the engine. So it's a gear reduction, 4.356 turns of the crankshaft to one turn of this housing. Well, that also turns this ring gear that's inside of our power transfer unit. So this whole thing now is sitting like this. And then off to the side here, facing towards the back of the vehicle, we have our pinion gear, and it's going to mesh right there. It's a hypoid, so it's off center, and this will drive the rear differential, or the rear drive shaft, rear propeller shaft. Here's a piece of the rear propeller shaft that's been cut off. It's got a universal joint on there. That is going to just slip right on there, and this sits right here. And so that means as the final drive differential ring gear is rotating at a gear ratio of 4.356 to 1 with compared to the engine, we have some gear ratio here in the power transfer unit. Now this actually is not an underdrive unit. This is an overdrive unit. And so the overdrive unit has a gear ratio here on the front transaxle of stupid B 0.439 turns to 1, which means we will turn almost half a turn, 0.4 turns of this ring gear to get 1 full turn of this pinion. So we're actually overdriving the pinion. So unlike a regular ring and pinion gear set where we put power to the pinion and drive the ring, we are connecting engine power to the ring gear and overdriving the pinion. And then that goes to the back of the vehicle. Now at the back of the vehicle, through our propeller shaft, we have another ring and pinion gear set of this exact same number of ring gear teeth versus pinion gear teeth, except now we are underdriving. And if you take the reciprocal or the inverse of 0.439, you'll get a gear reduction of 2.277 to 1. So that means if we flip this around, so at the front of the vehicle, this was facing backwards with a ring and pinion gear set, overdriving really fast. At the back, we've flipped it around. We've got the same ring and pinion gear set flipped over with a gear reduction of 2.277 to 1, turning our ring and pinion gear set in the back. That way the front tires and the rear tires turn the same speed. But here's the freaky thing. Remember, we've got an overall gear reduction in the transaxle. The gear ratio for the final drive transaxle here is 4.356 to 1. So the front differential has a gear ratio of 4.356 to 1. The rear differential has a gear ratio of 2.277 to 1. Now you might be thinking, what? I thought they had to be the same. Well, in a normal four-wheel or a regular full-size four-wheel drive truck or four-wheel drive sport utility vehicle, yeah, they have to be the same. So all 4 tires will turn the same speed. But the genius of this system is that since we are turning the front ring and pinion gear set with the front differential, as it turns and overdrives the pinion, and then it underdrives at the back, the ring gear with the same gear ratio, it really doesn't matter what the rear axle gear ratio is because it is always underdriven at the same gear ratio as the front ring and pinion gear set is overdriven. So what I'm saying is it's absolutely normal to have a different rear axle gear ratio than you will have for a front axle gear ratio. Now, that presents one problem, and that is the propeller shaft, the drive shaft here, this pinion at the front, the pinion at the rear, the 2 or 3 piece propeller shaft, drive shaft, and we'll go look at the vehicle here in just a moment that has one of these in it. That means this propeller shaft spins at a different speed than, say, the rear propeller shaft would spin of a full-size four-wheel drive pickup truck or SUV. And that's because it's overdriven off of the final drive rather than overdriven off of the back of the transmission or transfer case in a traditional four-wheel drive vehicle. So for vibration diagnosis, this speed right here is unlike any other rotational speed of any other part on the vehicle of any all-wheel drive or four-wheel drive vehicle. Now there is one more thing I need to show you before we go to the vehicle, and that is at the rear of the vehicle, where the pinion and the ring connect together, there is not a solid connection between the propeller shaft and the pinion. Instead, this is cut. It's cut in half. It's wide open. And what they have instead, depending on the vehicle manufacturer, is a multi-plate clutch pack like on an automatic transmission. And on this Toyota version, it has an electromagnetic actuator. So there's a wire on the side. It sends current through a big coil of wire, produces a magnetic field. There's a little ramp that these little balls roll up, and it actually causes another ramp to push against the multi-plate clutch to connect the front half of basically the pinion shaft to the rear half of the pinion shaft. And Toyota calls it active torque control, but General Motors has a version of this. Honda's used this for years. Chrysler, Ford, the Ford Escape, the Chevrolet Equinox, all of the new Jeeps, the smaller Jeeps that are front-wheel drive that also have an all-wheel drive or four-wheel drive version. That clutch pack, if it's an all-wheel drive vehicle, is only engaged when the four-wheel drive computer determines that the front wheels are slipping faster than the rear wheels are rolling. If you want four-wheel drive, then the clutch pack is permanently applied, like on some of the Jeeps. And I think there were some Ford Escapes that did the same thing. The all-wheel drive system, even though there's power delivered to the front half of the pinion gear, there is no power delivered to the rear wheels unless that clutch is applied, and it's only applied momentarily. Like when you first accelerate from a dead stop, whenever it detects a slip, and it's automatically disconnected whenever you decelerate or turn corners, because we do not want it to be in four-wheel drive when you turn corners because of the need for all four tires to turn a different speed. All right, so those are the internal components in a transfer unit, different than a transfer case. Now let's go over to a vehicle and I'll show you all these parts on the vehicle itself. Okay, we're over here underneath a 2009 Toyota Venza, but this just as easily could be a RAV4, a Lexus RX 350, a Toyota Sienna. This could just as easily be a Ford Escape, a Jeep, any number of front-wheel drive vehicles that also have an all-wheel drive or a four-wheel drive option. So let's take a look at the underbody here. As you can see, we've got the engine oil pan right here. Over here we've got the transaxle. This is the Toyota U660E 6-speed transaxle, and the transaxle comes over and ends right here at the pretty much where the exhaust pipe is, and then this piece right here is that power transfer unit that we had over there on the workbench. So let me hold up some pieces to help you recognize what's what. So right here would be where that ring gear would be mounted, and then we've got the axle shaft that goes over to the right hand tire, and then get that piece out of the way. Right here would be the pinion gear and the shaft sticking out the back that drives, and Let me move my head out of the way here, but you can see right here this piece going all the way to the back of the vehicle. We've got a 3-piece propeller shaft going all the way back to the rear differential. And so this power transfer unit is, once again, we've got a front wheel drive vehicle. We've got a power transfer unit here, the ring and pinion gear set inside of it that drives the ring, or the ring is driven off of the transaxle final drive. The pinion then drives the rear propeller shaft, and there's different variations on the propeller shaft as far as how many pieces it has, whether it uses U-joints or constant velocity joints and so on. And then back to the rear differential. Now let's go back to the rear differential and take a look at some of the components there. All right, we're at the rear differential, looking forward from the back of the vehicle. And as you can see here, we've got the differential housing, we've got the right and left hand axle shafts with CV joints going to the wheels, and then of course up in here we would have a ring gear with a differential gear set in it to allow for differences between left and right wheel speeds. And then sticking forward, we would have our pinion gear right in here. And then this housing right here on the pinion is where that multi-plate clutch pack is. And there is an electrical connection up in here. This multi-plate clutch pack assembly with the electromagnetic clutch. Now, some vehicle manufacturers use a viscous clutch in these models. Some use a hydraulic driven pump with a relief valve to either disallow or allow the clutches to apply. But the main point here is that on this propeller shaft that goes to the front of the vehicle, even though this is turning all of the time and it has power to it, that power stops right here at the entrance at the front of this rear differential housing. And it does not go through that multi-plate clutch pack unless the electromagnetic coil is energized by the four-wheel drive computer. And then power is sent to the ring and pinion gear set to drive the rear wheels. Now all of these will be turning at the same time, at pretty much the same speed anyway. But remember, we are not going to have power sent to these rear wheels unless the front tires break loose and are spinning faster than the rear tires are rotating, or on initial takeoff, just to provide four-wheel traction. And during some cornering maneuvers also, you will have some additional active four-wheel drive. And depending on the model, this clutch pack back here can be activated just temporarily, just long enough to give you power to get you out of that slipping condition, or it can be activated in a kind of an off-road mode where it gives you true four-wheel drive while you drive around. So this has been a demonstration of the crossover all-wheel drive, four-wheel drive systems that you can get on a normally front-wheel drive driven vehicle. Obviously, this is different than your traditional four-wheel drive full-size pickup truck or full-size SUV, where we have a front and rear drive shaft, not just a rear drive shaft, and a transfer case in the middle of the vehicle. This is totally different, and the propeller shaft spins at a different speed than either the front or the rear propeller shaft spin on a traditional four-wheel drive truck. Have a good day.